Okay, so in the last two segments, I've talked a little bit about the work we've done to improve darcs performance, and I've started to address the question of reliability. So first of all, how we are, what we're doing to make darcs e more stable on Windows, and now what we're trying to do to sort of improve the state of the darcs library. So there's basically two problems with the darcs library. The first of which is that it's not stable. We don't have a proper non-moving target to give to people. What we do have is just a set of modules that we sort of exposed through the appropriate Haskell mechanisms that people can sort of use at their own risk, knowing that at each successive darcs revision, we're actually quite likely to change quite a few things. Move functions around and whatnot. So this is clearly not satisfactory. This is the kind of thing that makes it very hard. This kind of moving target makes it very difficult to build useful applications with darcs, things like graphical interfaces and whatnot. And this is something that we need to address. The second problem is that the library, while it does have a sort of a rough separation into sort of core components like things that deal with the patch theory type operations, and repository level components, things that deal with just basically the kinds of files and sort of nitty-gritty details that it takes to make a darcs repository work on a daily basis, and into the actual darcs commands themselves. What we don't have is a very clean and principled sort of black box design for each one of these sort of sets of packages. And this is the sort of thing we need to aim for. We need to aim for a darcs library that somebody can pick up and just sort of use without worrying about accidentally corrupting their darcs repository, which is something that you could do if you're not very careful right now. So this is important not just for application developers, not just for people who want to build things like a darcs graphical interface, but also for darcs developers themselves. I mean, this is having a good, clean darcs library is something which would allow us to avoid introducing any bugs in the work that we do in the future. So this is one very, very important area that we are going to throw a lot of energy at now that we've started to sort of solve the more pressing performance problems. So that's for the short term. For the long term, what we need to do is to address some of the issues that we're facing with patch theory. So patch theory is basically, all the algebra of patches is what makes darcs darcs. This is the sort of the way of looking at patches and that makes it possible to take this view that a repository is just a set of patches. So to give a little history of this, there basically have been two versions of the patch theory. The first version, which is the one that basically most people are using, was very simple, but when it came to conflicts, what could often happen is that when you had sort of a series of operations, well, when you had operations that led to sort of a series of conflicts, you could find cases where darcs would either crash or just take an extremely long time to merge. It's actually sometimes could be exponential time with respect to the number of patches that are involved in conflict. So it took us several years to sort of address these issues and to sort of think about what we need to do to make patch theory a little bit more robust with respect to these kinds of conflicts. And the result of this thinking was the second version of patch theory, which came out in sort of early 2008. Now, this version of patch theory basically solves this sort of this infamous exponential merge problem for most people. I mean, for the usual case, a lot of the things that would cause darcs to sort of spin, a lot of very simple things, like for example, two people making the same exact modification to the same set of files, for example. These are things that darcs can actually handle fairly well now. Excuse me, sorry. But there's still two problems. The first problem is that while we have largely addressed the exponential merge issue in the second version of patch theory, there are cases that will make it happen. I mean, it's not completely solved yet. It's mostly solved for a lot of practical cases, but there are situations which involve nested conflicts where two people try to resolve the same conflict in different ways, and then they try to merge the changes again, and so you get a conflict of conflicts. That can still be fairly bad, and having long-term branches in darks can be quite painful as a result of this. A more serious problem is that there are still bugs in the theory. There are still a couple of cases where merging these kinds of complicated conflicts will basically cause darks to crash and emit sort of a nasty looking error message. Okay. Now, if this ever happens to you, basically what you need to do is to contact us either on the IRC channel #darcs and irc.freenode.net, or on the darcs users mailing list, or on the bug tracker bugs@darcs.net. And we will do our very best to sort of help you overcome this. What tends to happen in these cases is that you're basically merging in some very large complicated conflict involving conflicts of conflicts and other things like that. And you'll have to sort of manually port over the changes from one of the branches into the other. So doing an operation which is akin to git rebase. And what we will do is to basically help you to make this kind of recovery steps. Another thing we also do if you contact us is we'll actually use this kind of crash information to sort of study the patch theory and see where we've gotten things wrong. But what we need to do for the long term is basically we need to fix this patch theory thing. We need to kill this problem dead, right? And the way we're going to do this is well, we have work by a developer, Ian Linnick, who is working to formalize patch theory properly. Just really have very clean, rigorous definitions that are easy to check, and also to start to write proofs about the kinds of properties we would expect from a patch theory. And thirdly, just to actually just sort of rework the theory itself to have the kind of desirable merging properties that we need. One of the interesting aspects of Ian's work is that not only is this new patch theory going to be sort of more formally defined and have actual proofs associated with it. So these are proofs which are made with the help of a proof assistant like Coq or Isabelle. It will also have sort of guaranteed polynomial time merging behavior in the presence of conflicts. So this is sort of the holy grail for darcs, and where we'd like to move to as we've addressed a lot of the more practical concerns. So that's basically it for reliability. So sort of like a very local day-to-day issues like Windows, to more sort of developer-oriented issues like getting the darcs API under control, and finally the holy grail, like the big thing we need to get, which is the third version of patch theory, which gets it right. So we hope. Now let's look at the question of usability. In the last minute, I'm just going to talk about some of the more day-to-day usability improvements that we've made so far. One simple issue with usability is that a useful property of darcs is that when it comes to your patches, darcs is actually completely agnostic to the content of your patches. It doesn't really care what goes inside them. As far as darcs is concerned, it's just binary blobs, well, with new lines. This has this is actually very, very useful in terms of robustness and reliability, but it also has some practical consequences in terms of usability, which I will address in the next segment. So see you there. Thank you very much.